So hello everyone. In this tutorial, I'm going to discuss the surfaces. Surfaces are actually a very important aspect of any designing, whether you are into a product designing or the architectural. Because we use points and you interpolate, or we use different kind of methods to actually generate surfaces. So let's go and let's find out about the ways by which we can make surfaces. So surfaces is itself is found in a component palette. You can see there are many options right over there. Analysis, freeform, primitive, and utilities. Analysis, this is where we analyze the surfaces. Freeform, where we get various options to you know make surfaces. And the next one is primitive means you get already made surfaces, like here you can say box, cone, cylinder, quad sphere. So these are actually already made surfaces. And the utilities actually contain the lots of options, like dividing the surface, or flipping it, offsetting it, capping holes. So in this video I'm going to actually cover the free form, and I will be covering few of them. So let's see. Let's find out the ways by which we can make the surfaces. So let's start. So the first thing is the 4-point surface, which we can see from freeform, and here 4-point surface. So here you can see in the Rhino that I have 4 points right over here. So what we have to do, we just have to connect it with the surface, and you will see you will get a surface. So as soon as we connect the minimum 3 uh, points, we get a surface, and if you connect the fourth one, we'll get this one too. So we have the surface right now. So let's come here. Let me broaden my view. Wait, yes, I'm here. So the first here what we have is edge surface. What we do here, actually we define 4 edges as a boundary, which actually these edges can be moved and there won't be any error. So we will see it. So these 4 curves are actually internalizes in these. So let's connect first. So as I'm connecting, you can see I have just connected 2, and it have made a surface using those 2 curves. And let me connect the third one, and it have used the third one too, and the last one. So we have a complete surface. So let's try and move one. So you can see as I move the control surfaces, control points actually, we are seeing the changes in the surface actually. Let's hide it. Let's go to the next one. So our next example is actually the boundary surface. In the last one, if edge surfaces, if your corner points are not attached, there is no issue. But in case of boundary surfaces, the required thing is that these corner points would be connected. So you can see in the help it says create planar surfaces from a collection of boundary edge curves. So let's make one. So I have, if I select this one, you can see all of the 4 are visible here. So when I select, I get a surface. So let's turn off the preview for this one too. Let's go to the next one. As you can see, it looks like this one is a loft. Loft is a, let me plan it first. So loft is actually like kind of making a jumping surfaces. Actually you can see there are actually 2 curves. There are actually 2 curves where you connect it with the loft component. You can see there is a surface made here. So the other input is actually the loft option. So there is a different component for the loft option, which already have many the inputs which you can define, like type. And there is a option. The first one is actually closed. If you want a closed uh, loft, you can go for it. And let's go to the next one. Next one is actually the sweep. What happens in this sweep is, you can first, let me show you the curve. This curve is called actually the rail, and this one is actually the profile. What happens in this sweep is that the profile curve actually passes through the rail. So let's connect first. So this one is a profile, and this is, now you can see we have a particular curve we have generated. So the first one is rail and second is a section, and the other parameter is actually the kink meter type. What happens here if there is a abrupt change in angle, so you can define what should happen in those cases. Let's go to the next one. Our next curve is actually our next curve actually take UV curves. So we have to give the U curves and then the V curves. So the one of the important thing that you have to understand, what is the UV coordinates and what is the 3D coordinate. There's a difference between it. So I found a image on Wikipedia, which is I found it quite important. So if you can see, if the sphere, you can define its coordinates in 3D, 3D coordinate x, y, z. But if you open up it, if you can open it in in a planar map, then you start a coordinate system like a u in particular direction, v in particular direction, then you get a different kind of coordinate system. So if you use a 3D coordinates to define a sphere, and if you, then it will not be so even. But if you use the UV map, then it's actually even. When you are using rendering, then for if you are applying textures, then UV maps are actually used. Here you can see a particular example, like if we want to put this image on a sphere, then we have to actually follow the UV coordinates. So UV coordinates are used. So here you can see in this example, actually the first one is a surfaces in u direction, and next one is, and UV coordinates are actually perpendicular to each other. Now this one is these curves are actually following the u, and these are the v. So let's connect them. Now you can see their connection is here, and we get a curve. And the last one is actually continuity. If you click on help, you will get more information. And not this one. Yes. Yeah, the last parameter actually cares about the surface continuity. So we define the values 0 to 3 according to our need. So next one is the extrude. Here you can see as a curve I have a circle. So let me connect it with the extrude, and this one is actually a unit z vector, and this one for the magnitude. So we get a magnitude of 4.4 vector in the direction of z. So let me connect it. So when I turn on the preview, you can see we have a extruded cylinder. So the last one is quite interesting. You will like it. So last one is actually a revolve. Revolve is actually what it is. Let me tell you. So what we do in revolve, we take a curve and we take an axis. What we do, we actually rotate around it. So the first, this is our profile, and this is our axis. So let me connect it. So you can see revolved object. Now the next input is actually the degree, like how much angle you want to rotate, so you can actually control it. So here we stop. You can see we have covered a lot of ways to make a surfaces. In the next video I'll be covering the processes where we can analyze the surfaces.